about voltage, energy, and power. So, as last week, we have discussed about the introduction, about the different materials that are used in electrical engineering and electricity, and also our current and charge. So, yan. So, as we all know, pag meron kang kuryente, pero wala kang voltahe, the circuit will not work. Okay? So, parang example, yung human body. Yan. So, the voltage is what you call the heart of the circuit. So, what do the heart do? The heart pumps the blood into our veins, okay? Which is talot, kumbaga. So, from this, pag wala tayong voltahe, walang magpa-pump ng charge sa different uh, circuits or sa different elements na kailangan nating supplyan. Okay? So, voltage is actually the energy needed in order to make every charge move. Yan. So, pag nagkaroon ng movement ng charge, meron tayong current, which is I equals dq over dt. So, therefore, since I is equal to dq over dt, we may say that the voltage is equal to dw over dq. Yan. So, voltage or VAB is the energy required to move a unit charge to an element measured in volts. So, itong voltahe na to, ito yung gagamitin natin para makapagbigay tayo or para makapag-move tayo ng charge from high potential to low potential. So, yan. So, bibilisan ko lang ang discussion, no? Para matapos natin. Okay. So, voltage. Pag electromotive force, EMF, ito yung ginagamit nating term for those voltage or material or voltages that is produced in our battery. Pag battery yan, ang tawag dyan EMF. So take note na pag battery ang ginagamit mong voltage source, nauubos yan. Okay? Kasi meron tayo limited na supply ng charge sa isang battery. Okay? So electromotive force, chemical reactions. So ito yung ating battery. Okay. So bakit battery yung inuuna ko, no? Actually, battery is the simplest. Siya yung pinakasimpleng DC source ng isang circuit. So, this is the diagram or yung practical diagram ng ating battery. Okay? So, as you can see, yung voltahe na lumalabas sa battery mo, pag nilalagyan mo rin ng load, is not actually the EMF. Yan, yung 1.5 volts. May kasi, sa loob ng battery, meron tayong tinatawag na internal resistance. Okay? So, ito internal resistance na to, parang siya yung voltage drop inside the battery. Take note that every material has what you call your resistance. Yan. So, kahit kayo may resistance kayo, so therefore, nag-absorb kayo ng voltage drop. Yan. So, in this circuit, you can see that internal resistance, tapos meron din tayong another R. Yan. This R is our load resistance. Pag sinabi nating load resistance, ito yung resistance ito yung sinusuplayan natin. So, pag nagkulang yung voltahe, example, yung battery mo, nauubos na, di ba, sa cellphone, nag-warning yan, tapos pag naubos yung charge, 3%, 2%, 1%, hanggang 0, so papatay yung cellphone mo. Ganun ang mangyayari sa isang practical battery pag naubos yung charge natin. So, the charge of a battery is represented by this graph. So, of course, ohms to, V is equal to IR, which is posted into your LMS. But technically, submitted na natin to i-magnify yung information about your ohms law. So, ito yan. EMF, ito yung EMF value na pinoproduce mismo ng chemical reaction sa loob ng battery nyo. So, sa battery, every material has a resistance. So, therefore, sa loob pala ng battery, nababawasan na yung EMF value mo. So, yung value na to, which is called yung terminal voltage. So, yan. VT, or terminal voltage, is equal to E, less yung voltage na kinukuha ng ating tinatawag na internal resistance. Yan yung voltage drop natin. So yung voltage drop natin is ito. Voltage drop, terminal voltage wherein pupunta sa load is this voltage. Okay? Papunta yan sa resistance natin. So that voltage or that voltage or the charges that are present in that voltage, yan yung gagamitin ngayon ng load resistance natin until such time na maubos yung charge. Sir, posible bang unlimited yung charge? So napakagandang tanong. Pwede, basta unlimited yung resources mo. So example, yung cellphone mo. Pag nag-charge ka habang gumagamit, okay lang, di ba? Kasi nadadagdagan pa rin yung charge. Ayan. But, in the case of a car battery, hindi mo pwedeng gawin yan. Why? Basically, sa isang car battery, mas mabagal mag-charge kaysa kainin yung charges. So, hindi nyo, matatry nyo yan pag may thesis kayo sa electrical engineering. Kahit sobrang taas ng isaksak mong bot, na bilis ng isaksak mong kuryente para pumasok yung charge dyan, para mag-charge siya na mag-charge. Tapos gagamitin mo lang din ulit ng diretso, hindi katulad ng cellphone mo. The tendency is that hindi mapupuno yung car battery. So yan. Okay? So ito. So internal resistance, as I have said, is the resistance inside our battery. Okay, internal resistance yan. Ano tong open circuit voltage? So open circuit voltage. Yeah. What is an open circuit? So in this diagram, you can see that ito yung battery natin. So negative, positive. Of course, meron tayong internal resistance. So yan. And then, ito yung ating wire papunta sa ating resistance. So pag sinabi nating open circuit voltage, ibig sabihin nun, wala tayong isasaksak dito. So tanong, may current ba or wala? Practically, sa isang open circuit, I is equal to 0. Take note dyan at open circuit, I is equal to 0. Bakit? Ang analogy dyan is parang faucet, di ba? Di ba yung gusto mong, yung faucet ng isang fountain na pabalik-balik, di ba? Papasok, babalik. Practically, pag open yung faucet ko, yung buong circuit mo, hindi lalagyan, tama ba? So, maubos lang siya dito. So, pag gano'n, natapon lang yung circuit mo. So, therefore, walang current na pumapasok sa buong circuit. So, parang gano'n yung analogy niya. So, take note that at open circuit voltage, at open circuit, the current is 0, but itong terminal voltage na sinasabi ko sa inyo is equal to yung highest voltage mo, which is ito. Okay? Yung EMF. VT is equal to E. Ayan. So yung mga nakikita nyo, mga 1.5 volts, ganyan sa mga battery, that is what you call the open circuit voltage or the EMF voltage. Ito yung pinoproduce niya pag naka-open circuit siya. So yan. Next is yung load resistance. So discuss ko na to. So yung load resistance natin is any resistance of our load. So ano nga ba yung mga load natin? Anything that needs electrical energy. So yan. So take note that most loads sa DC circuit ay represented by resistor. Yan. So because a resistor is the part of the circuit that absorb power. Hindi ang gagawin ng isang resistor will absorb power. Hindi siya magde-deliver. So yan. So yan lang yung isipin mo pag resistor yung pinag-uusapan natin. Okay? So basic quantities, you have our voltage. Ito. So as in the case of our current, we must assume a positive direction. Sa voltage naman, meron tayong tinatawag na polarity. Right? So, minsan kasi, hindi ko na-discuss ito kanina. Ang other term, para makita mo yung high potential, ganito. Pag walang AB, tapos sinagyan ng arrow, ganito. Ang ibig sabihin nito, yung arrow na to, indicates high potential. Ito yung high potential mo, ito yung low potential mo. Okay? So, pang-pan ko sana yan, pang-quiz. Hindi ako maglalagay ng positive, negative, no? But probably, so yun, nasabi ko na. So, yan. So, take note that at VAB, siya yung A mo is your higher potential and B is your lower potential is equal to negative of our VBA. So, yan. So, VAB is equal to negative VBA. So, at this point, yung 9 volts natin is at VAB. Okay? So, VAB is equal to positive 9 volts. So, VAB is equal to positive 9 volts. So, therefore, pwede kong sabihin that VA dito, from negative to A, is equal to negative 9 volts. Ayan. In this part, or in this diagram, parehas lang sila ng ibig sabihin. So, paano mo nasabing parehas sila ng ibig sabihin? Negative 9 volts to. So, ayan. So, take note that in this case, ang VBA, yung B natin is the high potential. Ito yung high potential natin. High potential. Tapos, yung A natin, yung ating low potential. Pero, tignan mo naman to. Binaliktad din natin yung sign. Okay? So, in this case, you may say that VBA, ito yung high potential to low potential natin, is equal to 9 volts. Diba? So, from the diagram, so therefore, I may say that VAB is equal to negative. So, negative of VBA is equal to negative VBA. So, yan. So, therefore, I may say that negative of negative VBA, so multiplied by negative 9, I will have a value equal to positive 9, which is parehas lang sila dito. Diba? Okay. So, in another thing, ang ginagawa ko kasi, pag VAB at VBA, ang AB, A to B, yan, parang from A to B, from direction A to B, is yung A and B indicates the direction, di ba? So, high potential to low potential. Dito naman, VBA, from VB, higher potential to low potential A. So, parang gano'n yung analogy niya. Okay? Next. So, let's have our power and energy. So, bibilisan ko lang para maka-cope up tayo mamaya sa mga examples natin. Okay. So, for power, take note. That power, ang unit niyan is watts, di ba? Watts. So, watts is indicated as so power. You have what you call our watts. Ito yung unit ng ating power. Yan. But, ano nga ba tong watts? So, watts means this is equal to our joule per second. Or ano yung joule? This is our energy per time. Okay? So, that is our power. But, another term for power is equal to dW over dt. Pag instantaneous yung pinag-uusapan natin. So ano ba itong instantaneous power? Instantaneous power is produced tinatawag natin is produced by instantaneous voltage and instantaneous current. So, pag sinasabi natin instantaneous, from the word itself, instantaneous at a certain time, at a certain time, di ba? Parang graph, di ba? Graph yan. So, hindi siya constant, kaya instantaneous. But in this term, we have dW over dt. Paano pa natin nagagawa tong dW over dt? Di ba? Para naging biglang energy per second. Probably, if you would dissect the equation via chain rule na tinatawag natin, we all know that in order to make a charge move, we need a energy, which is equal to dW all over dQ. Right? Which is equal to our but hindi naman makukompleto ang isang circuit if we would not take the time wherein the charge is moving, which is basically our dQ over dt, which is our current. Okay, so P is equal to VI, therefore. So rearranging the equation, we'll have a value equal to dW over dt multiplied by dQ over dQ. Technically, dQ over dQ is equal to 1, diba? Kasi parang divide. But, this is the derivative of charge with respect to Q, or dx with respect to x. Derivative of x with respect to x is equal to 1, right? So, dQ over dQ is equal to 1. So, therefore, we will have a value equal to dW over dt multiplied by 1, which is equal to dW over dt. So, from that perspective, pwede kong sabihin that my power in electrical terms is equal to VI. Okay? Power is equal to VI. So, yan. So, relating your power to energy, pwede nating sabihin that since P is equal to dW over dt, I may say that dW is equal to P dt. Okay? So, pag kinuha natin yung integral of both sides, letting W is equal to 0, and then meron tayong W, so therefore, I may say that W is equal to the integral of P dt from a certain time 0 or TO, let's say TO na lang, to a certain time that you would want the power to be supplied or energy to be supplied. Okay? So, from that sense, dapat, since we are dealing with different units, ayan, kailangan nyo lang din naman to as you go on with your electrical engineering journey, I should say. As you go on with your engineering journey, so of course, you must be aware of the different types of our SI units. Pag BTU, or pag English, or pag SI, mga ganyan. So, dapat medyo gamay nyo rin yan. And then, of course, yung ating mga notations. Okay? Because, siyempre, board exam, no? Yun talaga yung pinag-ahandaan nyo. And then, real world, no? Hindi mo naman masyadong pinag-ahandaan pang real world. Kasi nga, hindi ka naman makakapasok sa real world or engineering world pag hindi mo nakuha yung lisensya mo. Okay? So, ganyan. Okay? So, that is power and energy. So, power is equal to VI. So, na-derive ko na to. The instantaneous power, as I have said, is a time-varying quantity. Okay? So, yan. Yung ating tinatawag na passive sign convention. So, the movement of current that I will discuss, may dalawa, di ba? Meron tayong conventional flow at meron tayong tinatawag na electron flow. So, dito natin ma-apply yung dalawang yan. But particularly, magko-conventional flow tayo, which is from higher to lower. But, we would depend, para hindi tayo mahirapan, is yung tinatawag nating passive sign convention if we are dealing with power. So, ang isipin mo lang dyan, pag passive sign convention is kung saan sign papasok yung current mo at kung ano yung magnitude ng current mo. Okay? So, dito. So, passive sign convention is satisfied when the current enters to the positive terminal of an element and P is equal to VI, and if the current enters to the negative terminal, P is equal to negative VI. So, in this diagrams, syempre, pinapakita natin dito kung paano ba yung direction ng current, yung magnitude ng current, and of course, yung assumptions mo and the polarity. So, yan. So, isisingit ko lang ulit, no? Yung ating positive and negative PIs. So, last meetings, I have discussed about the different types of element. Meron tayong two types of element. We have our active and our passive element. So, huwag niyong kakalimutan yung ating active at yung ating passive element. So, active and passive element. Active and passive. When we say active, they are the ones who are producing and delivering power. So, deliver. Pag mga passive naman, sila yung mga nagre-receive at sila din yung mga taga-absorb or taga-store. Ito yung ginagawa ng ating passive. Ang pinakakilalang passive element natin is our resistor. Okay? So, paano mo masasabing passive siya or paano mo masasabing absorbing siya or paano mo masasabing receiving? Ayan. So, pag we have a negative power that you would compute, power is equal to negative, meaning this is delivery. Pag positive naman, meaning this is always absorbing. Absorbing or ito yung taga-receiver. Taga-receive. So, yan. So, from this diagram, so papakita ko lang sa inyo. So, mapapansin mo that this is positive VI. So, how is it positive VI? So, from the definition itself, kung saan papasok yung current mo. So, consider this two terminal ng ating element. So, yung I mo is that kung makikita mo, no, palabas siya sa positive. Pero papasok siya, as I have said, papasok siya, I should say, sa terminal ng ating element. So, yung element natin, pumasok sa positive, or kung nagdududa ka, ang gagawin mo, papaikutin mo lang siya. Papadaluyin mo lang siya sa pungong stickit natin. So, pumasok siya sa positive. So, therefore, yung magnitude ng I natin is positive. So, therefore, the direction is positive, no? So, P is equal to positive I. Tapos, yung pinagpasukan ng ating current is sa positive side ng ating V. So, therefore, positive P. So, therefore, from this, you may say that P is equal to PI. Okay? Next. Dito sa diagram na to. Sa diagram na to, makikita mo that the current is going out the positive. So, bakit sa going out? Kasi itong terminal voltage natin, makikita mo, yung current natin palabas. So, saan siya papasok? Kung nagdududa ka pa rin, with the direction of the current, papaikusin mo siya o papadaluyin mo siya sa circuit, pupunta dito. So, you will see that it is entering the negative terminal of our voltage. So, therefore, power is equal to positive I multiplied by our negative terminal ng ating voltage, so negative V. So, therefore, we'll have a value equal to negative VI. Okay? Ayan. So, let's test our theory. Kung tama ba siya o pwede ba siya. So, dito tayo. So, take note that these two circuits are equal. Parehas lang yan. So, paano ko nasabi? Ito. So as you can see, your 3 ampere is entering our positive terminal. Okay? So entering the positive terminal, pag pinaikot ko to, pasok siya, di ba? So therefore, we have power is equal to positive 3 multiplied by positive 4. Pumasok siya sa positive value ng ating voltage, which is equal to positive 4 volts. So therefore, we'll have 12 watts. Ayan. So this is our diagram A. So paano naman sa diagram B natin? So paano ko siya nasabing parehas lang? So actually, this is our diagram B. So mapapansin nyo that 3 ampere is palabas siya sa negative. Pero pag pag diniretso ko siya with its direction, you can see that papasok sa positive. So therefore, power is equal to positive 3 and pumasok sa positive value ng ating 4 volts. So therefore, this is equal to 12 watts. Yan. That is so positive. So how about in our diagram number 2? Sa ating diagram number 2, ito. So as you can see, your 3 ampere is going out to 4 volts. The terminal of our 4 volts. So pag hindi ka sure, papaikutin mo lang siya, pumasok siya sa negative ng 4 volts. So therefore, power is equal to 3. Bakit positive 3? Kasi nga, at that direction, you have a positive value or positive magnitude of 3 ampere. So positive, and then, pumasok sa negative value ng ating 4 volts sa negative 4, will have a value equal to negative 12 VA or negative 12 watts. So take note that alternative unit for watts in DC circuit is VA. Okay? So yan. Next. Dito tayo sa isa. You can see that this is 3 ampere. Okay? So 3 ampere to. So ang gagawin natin dito sa 3 ampere, so makikita mo na agad na pumasok sa negative. Diba? Pag hindi ka pa rin sure na papasok talaga siya dyan, papaikutin mo lang. So yan. You can see that negative. So therefore, power is equal to, yung 3 ampere natin, pumasok siya sa negative value ng ating 4 volts. So negative 4, di ba? We have negative 12 volts. So ganyan. So ganyan lang ang ating passive sign convention. Pag hindi nyo magamay, so pag hindi kayo sure, pag papasok siya or hindi, ang gagawin nyo, papaikutin nyo lang, di ba? Total, halos lahat namang ganyan, no? Sanay magpaikot. Ay, joke lang. Okay? So ganun. So ganun lang yung gagawin nyo. Papaikutin nyo lang or papadaanin nyo lang yung current. Papasok or palabas sa isang terminal. Okay? So that is our passive sign convention. Next. So, this is our summation of power. Take note that conservation of energy tayo. So, walang nasisira, pero walang nagagawa. So therefore, summation of P is equal to 0. So, power absorbed is equal to the negative of power supplied. So, paano ba yan? So, pag ginawa natin yan, summation of P so is equal to, syempre, total power is equal to power absorbed plus power supplied. But, what is power absorbed or power supplied? Diba? So, kahit alin dyan ang pwede nating i-substitute. So, from this, I will have my power absorbed, which is equal to negative power supplied. So, negative power supplied, substitute ko yung value nito. So, plus positive power supplied. So, therefore, this is equal to 0. So, summation of P is equal to 0. So, magagamit natin ito mamaya sa ating mga examples. Okay? So, yan. So, okay. So, yan. Summation of P is equal to 0. Electrical energy tayo. So, what is electrical energy? Itong electrical energy, ito yung ginagamit natin para i-measure actually yung mga kanya sa bahay, kilowatt hour. Okay? So take note that kilowatt hour is a measurement used in energy. Okay? So para naging energy yun, diba? Energy or W is equal to watt, or watt is equal to joule second. So pag multiply mo ng hour to, so makakancel dapat yung dalawang time. So therefore, that is already a unit for our energy. Okay? This is, wait lang. Baka magkalituhan tayo sa ating unit. Okay. So dito tayo. W. W is for energy. Okay? So W is equal, so power to. So power is equal to what? So we have joule per second. So pag gusto natin gawing energy which is equal to W, so therefore joule per second or joule per time multiplied by hour. So therefore we have watt hour. So pag ginawa natin kilowatt hour, so therefore kailangan mo ng times 10 raised to 3, di ba? So kilowatt hour. So yun yung ating kilowatt hour. So kilo means times 10 raised to 3. So ang ginawa niya dyan, hindi niya ginawang second yung hour. Diba? So kaya kilowatt hour. So kilowatt hour is a measure of energy. So 1 kilowatt hour is equal to 1,000 watt hour. So from this, pwede natin sabihin that kanina dinerive ko na to, that energy, so W is equal to the integral of P dt. Or in magnitude terms, W is equal to P multiplied by T. Okay? So yan. W is equal to P dt. But technically, we all know that V is equal to dW over dQ, no? So therefore, pwede ko yung sabihin na pag yung dQ natin is yung ginagamit natin yung magnitude niya, so W over Q. So therefore, pwede ko rin sabihin that W is equal to V multiplied by Q. Okay? So unit for W as a unit, ito, joule. Okay? Huwag nyo kakalimutan yung joule natin. So yan. As a unit for energy store. So yan. That is for energy. So electrical energy, ito lang yun. Integral of P dt, but since P is equal to VI, substitute lang natin dito. So therefore, integral na yan ng VI dt. Okay? That is our electrical energy. Okay, so let's have our conceptual problem for this topic. Okay, so let's have our problem number 1. Pa-calculator nyo na lang, no? A rechargeable flashlight battery is capable of delivering 85 milliampere from about 12 hours. How much charge can it release at that rate? So if its terminal voltage is 1.2 volts, how much energy can that battery deliver? Okay. So in every problem solving, ang pinaka technique natin dito is to conceptualize. Okay? So paano ba tayo mag-conceptualize? First things first, what are the given? Diba? So what are the given? We have I, which is equal to, so lalagay ko dito, letter A, solution. So what is our I? We have an answer equal to, a value equal to 85 milliampere. Okay? Another, we have our time. Time which is equal to 12 hours. And then, next is yung tinatanong ng problem. It is charge. Okay? So we have our Q, which is equal to known. And then, yung voltage, 1.2 volts. V is equal to 1.2 volts. And lastly, is our energy, which is another na tinatanong. Okay. So from this, letter A, tinatanong nyo kung anong charge. Letter B, tinatanong mo kung ano yung energy. So take note that there are many ways to kill a chicken. So kahit ano, solution, pwede. Basta pwede mong gamitin yung formula. And then of course, wag ka na, ang pinakamaganda dyan is yung theory side. So dapat wag ka magde-deviate sa ating theory. Okay? So from this, first, kinukuha natin kung ano yung charge na kailangan natin. So therefore, letter A, so I, we all know, is equal to dq over dt. But it is also can be rewritten as our magnitude of q over magnitude of t. Okay? So from here, I will have a value equal to 85 milliampere for my I. Okay? Equals, of course, kung ano yung q ko, divided by my t, which is equal to 12 hours. Okay? So, yan. So, dito pumapasok, again, kung paano mo i-dissect yung mga natin, yung ating mga kung paano mo i-dissect yung ating mga units. So, we all know that 85 milliampere can be written as 85 times 10 raised to negative 3, and ampere is equal to coulombs per second. Okay? So it is equal to our Q over 12 hours. So from here, pwede kong sabihin that my Q is equal to 85 times 10 raised to negative 3 coulomb per second multiplied by my 12 hours. Okay? So from this, we have 85 times 10 raised to negative 3 coulombs per second. Another step is gawin natin parehas sa second chat. So we have 12 multiplied by, so wag ko munang gagawin. So ito muna. So 12 hour multiplied by 60 minute per hour, and I have 60 second per minute. Okay? So canceling out my minutes or my terms that are units that are similar. So ang gagawin natin, tatanggalin lang natin itong R, tatanggalin natin itong minute, kakancel natin yun kasi 1 lang yan, and then yung S natin. So matitira is yung ating 85 times 10 raised to negative 3 multiplied by our 12 hour multiplied by 60 multiplied by 60. Okay? So we'll have a value equal to 3,672 coulombs. So that is our charge. Okay? So, pag hindi kayo sumusunod with your calculator, so ako nang magka-calculator para sa inyo. Okay? So, easy. We'll have 85 times 10 raised to negative 3 multiplied by 12 multiplied by 60 multiplied by 60. Okay? So, we have 3,672 columns. Okay? Next is letter B. Actually, pwede ko nang diretso to. But for the purpose of explaining our formula, ilolong cut ko muna. So from this, we have, if its terminal voltage is equal to 1.2 volts, how much energy can be delivered? So actually, we all know that volts is equal to energy per charge. Ang gagawin lang natin, pwede ko lang W is equal to VQ, di ba? Which is equal to 3,672 coulombs multiplied by my volts, which is equal to 1.2 volts. But what is my volts? Is equal to 3,672 coulomb multiplied by 1.2 volts is equal to charge per work per charge, which is equal to joule per coulomb. So makakancel yung coulomb natin, which is equal to 4406.4 joules. Okay? So, yan. So, multiply lang tayo ng 1.2. Okay? But, another thing na pwede natin gawin is ipakita natin kung ano yung pwede natin gamitin yung power equation natin. So, we all know that power is equal to VI. And my power is equal to, my voltage is equal to 1.2 volts. And I have my 85 milliampere. So 85 times 10 raised to negative 3. So from here, I will have 1.2 multiplied by 85 times 10 raised to negative 3. So note, this is ampere, no? Kasi nga, credit na natin yung times 10 raised to negative 2 dito. So we have a value equal to 0.102 watts. Okay? So 1.2 times 10 raised to negative 1.2 multiplied by 85 times 10 raised to negative 3. Okay? So 0.102 watts. Okay? So from that, pwede kong sabihin, ang kinukuha natin is energy. So therefore, P is equal to 0.102 watts, right? So I know that my energy is equal to my PT. Okay? Or power multiplied by time. So we have 0.102 joules per second multiplied by time, which is equal to 12 hours multiplied by 60 minutes per hour multiplied by 60 seconds per minute. So makaka-cancel. So yan, we'll have a value equal to, so multiplied by 60 multiplied by 60 multiplied by 4406.4. Parehas lang sila. Joules. Okay? So times 12 times 60 times 60. 4406.4. So they are equal. So in either ways, they are correct. Okay? So let's have our letter B. So an energy source forces a constant current. So ibig sabihin, bibigyan niya daw ng bibigyan yung light bulb ng 2 ampere for 10 seconds through a light bulb. So if 2.3 kilojoule is given off in the form of light and heat energy. So take note, no, pag gumagamit ka ng light bulb, meron tayong light and heat energy na produce. So pag incandescent yung light bulb mo, mas mataas yung heat mo, mas konti yung light. Pero pag LED, mas mataas yung light mo, mas konti yung heat. Yan. Okay? So light and heat. So calculate the voltage drop across the bulb. So voltage drop meaning yung voltage na kinuha or napunta sa bulb. So pag kinuha natin yung diagram nito, this is your voltage source. Okay? So yan yung voltage source mo, papunta yan sa ating terminal voltage, which has a load equal to a bulb. So square na lang, mas maganda sa loob. Okay? So this is our V bulb. So according to the problem, the VS or voltage source is forcing at 2 ampere. So napakalupit, forcing, no? So 2 ampere at the time is equal to 10 seconds. Okay? So ito yung I natin na pumapasok sa ating light bulb. So take note, light bulb yan, ibig sabihin nag-absorb yan ng power. Okay? So positive dapat yan. So at an energy of 2.3 kilojoule. So energy daw na ginagamit niya para pumasok yung 2 ampere dito is 2.3 kilojoule. So 2.3 kilojoule. Yan, sobra. Lakas. So 2.3 kilojoule, 2 ampere. Of course, pag nahawakan mo yung 2 ampere, patay ka na dyan. So, from that, ang kinukuha natin is yung tinatawag natin voltage drop. So, paano ba yung magiging diskarte nito? So, sa isang problem solving, matuturo lang sa inyo yung mga formula, pero yung diskarte, sa inyo na yun. Okay? So, kung paano yung analysis nyo. So, dito, ang diskarte ko is that kukunin ko muna yung power ko. Diba? So, bakit kukunin ko yung power? Kasi, power is equal to VI. Diba? Pagkakuha ko ng power, may V naman ako, ay may I naman ako, makukuha ko yung V. But my power is also equal to energy per time. Okay? Which is equal to, yung energy ko is equal to 2.3 kilojoule. Tapos yung time ko is equal to 10 seconds. Di ba watts yan? So it is equal to 2.3 times 10 raised to 3 or over 10. So we have 230 watts. Okay? Sa mga hindi nagko-compute, so compute ko na dito. So we have 2.3 times 10 raised to 3 divided by 10. Okay? So we have 230 watts. So, paano din yung voltage? So, lalaroin lang natin itong formula. Power is equal to VI. Okay? So we have 230 watts, which is equal to 230 VA. Di ba? Parehas lang yun. And my V was unknown. So, unknown yung V natin. So, V bulb multiplied by our I. So, ano yung current natin? Which is equal to 2 ampere. So, from here, I will have, cancel yung ampere. 230 over 2 is equal to my V bulb. So, therefore, our V bulb is equal to 115 volts. Okay? So, dito. So, yan. So, that is our voltage. Okay? So, yan. Okay guys, so pag nabibilisan kayo or medyo naguguluhan, just feel free to ask. Yan, hindi ko naman pinapagdamot yung karunungan ko. Okay? In these terms. And of course, pagkatapos natin ng discussion para mabilis. Okay? Pwede mo naman akong i-chat personally. Okay? So yan. Next is our third problem. So to move the charge Q from point A to point B requires negative 30 joule. So negative 30 joule daw yung ating point A to point B natin. Parang ang VAB natin dito, okay? So VAB natin. So pag ito yung positive mo at ito yung negative mo, yung kanya is 30 joule. So meaning VAB mo is equal to negative 30 I should say. So negative 30. Okay? So negative 30 joule. Parang ganyan yung diagram niya. So find the voltage drop is A is equal to 2 coulombs and if B is equal to negative 6 coulombs. Okay. So, ang isipin lang natin dyan is yung simple concept ng voltage which is equal to dW over dQ or in magnitude terms is that the magnitude of W divided by the magnitude of charge, di ba? So, meron tayong given na W which is equal to negative 30 joule. So, letter A, yung Q natin is equal to 2 coulombs. So, therefore, our V is equal to negative 30 over 2. So, mapapansin nyo, joules per coulomb. So, we have negative 15 joules per coulomb or is equal to negative 15 volts. Okay, so calculator pa rin natin yung 30 over 2. Baka mamaya mali pa yung 15. No? Sa board exam, kahit 1 plus 1 talaga, kinakalculator mo yan. Baka nagkamali ka pa, di ba? Baka mamaya masulat mo 1.8, di ba? So therefore, we have V is equal to negative 30 over 2, which is equal to negative 15. Next is at B, at Q is equal to negative 6 coulomb. So negative 6 coulomb, so therefore, V is equal to W over Q, which is equal to negative 30 joules all over negative 6 column. So I will have a value equal to negative 30 over negative 6 is equal to 5 joules per column, or our 5 volts. So yan. Okay? So kanyan lang kadali ang electrical engineering, guys. Parang linalaro mo lang, di ba? So yan. Okay? So, re-recap ko lang yung solution natin. Sa first problem, kinuha muna natin yung charge by using our theory, I is equal to dq over dt. And then of course, kinuha natin yung either power or kinuha natin yung formula ng voltage, which is equal to W over Q. Second is that, syempre kinuha natin yung power kasi nga meron na dating seconds at yung ating energy. And then after natin pagkakuha ng ganon, is kinuha natin yung voltage drop from P is equal to VI. And then third is that kinuha natin yung voltage or voltage drop across that element by simply using the formula of W over Q. Okay? So ganun lang. Okay. So dito i-apply natin yung tinatawag nating passive sign convention na naturo kanina. So dito tayo. Okay? Sa first diagram. Sa first diagram, so ito yung A, B, C. So at our diagram A, we have 4 ampere. So yan. So power is equal to, take note, yung 4 ampere natin, mapapansin nyo, papasok sa positive. So you'll have positive 4 ampere of my current multiplied by my positive 10 volts of my voltage. So therefore, we have a value equal to 40 VA. Yung power natin. Okay, 40 VA. Or it is equal to 40 watts. Okay, that is our power. So, another. Dito tayo sa letter B. So, letter B, we have, okay. So, yan. Mapapansin mo sa letter B, palabas siya ng positive, di ba? So, pag hindi ka sure, ang gagawin mo, papaikutin mo na naman siya. Di ba? Yan. Siyempre, tanongin mo yan. Baka na wrong set ka pa, no? So, papasok ka sa yung 2 ampere, papasok sa negative 12. So, therefore, our power here is equal to positive 2 ampere multiplied by pumasok sa 12 volts, di ba? So, negative 12 volts. So, you have a value equal to 2 multiplied by negative 12. So, you have negative 24 watts. Okay? So, sir, ba't naging negative? Ito, kasi pumasok ka sa negative. Okay? Siyempre, yan. Next is ito. Okay. In this part, take note, ito. You have negative 3 ampere. So, pumasok sa negative. So, therefore, my power equal to negative, I should say, negative 3 ampere for my current. So, P is equal to IB or BI. And then, yung negative natin, pumasok sa negative 5 volts. So, therefore, I will have a value equal to positive 15 PA. Okay? So, that is equal to 15 watts. Okay. Sir, pwede mo bang i-recall yung sinasabi mo sa amin na pwede mong baliktarin yung current? Siyempre, pwede. So, ito, pwede ko itong baliktarin actually. Di ba, papantayan dito, pwede ko itong baliktarin pataas. No? But, as long as babaliktarin mo rin yung polarity, so magiging 3 ampere to, positive. So mapapansin mo, palabas siya ng negative. So pag pinaikot ko, papasok siya sa positive, so parehas pa rin siya. So power is equal to 3, positive 3 ampere, which is yung binaliktad ko, multiplied by positive 5, which is equal to 15 watts. So either way, sa diskarte mo, basta tama yung diskarte, And then yung naayon sa theoretical value. So therefore, correct yung sagot mo. Okay? So parehas lang. Tama. So how about the other examples? So try natin to. Try natin to may negative. So ito, di ba, positive to. Ngayon, pag gusto kong baliktarin, yung direction ko, gawin ko ganito, papasok. Siyempre, babaliktarin mo rin yung magnitude ng 2 ampere mo, gawin mo negative 2 ampere. So, mapapansin mo, hindi yung negative 2 ampere mo, power is equal to negative 2 ampere, papasok sa positive ng 12 volts. So, therefore, it is also equal to negative 24 volts. Right? Di ba? So, gano'n lang yun. Para ka lang nagsusolve ng force diagram at moment diagram. Okay? So, directions. That's our problem number 2. Okay. Dito muna tayo sa problem number 2. So, ulitin ko lang yung naging procedure natin sa problem number 2. So, dito, in-apply natin yung passive sign convention wherein we would enter to the positive, we would use the polarity of the voltage where our current will enter the terminal. Okay? So pag pumasok yung positive current natin sa positive terminal ng voltage, therefore we would use the positive voltage. So magkakaroon tayo ng positive power. So pag pumasok naman yung power, yung current natin sa negative terminal yung voltage, at yung magnitude ng current natin is positive, so therefore we would create a negative power. So pag pumasok naman yung isang negative terminal, negative magnitude ng current sa isang negative terminal ng voltage, so therefore mag-create pa rin tayo ng positive power. Okay? So yan. So for our problem number 3, okay, so yan na naman yung differential calculus at integral calculus natin. So hindi talaga mawawala yan. Okay? Because this mathematics are the foundation of every engineering science. Okay? So the charge entering the positive terminal of an element is Q equals 10 sine 4 pi t millicoulomb. Take note of the unit, it is in millicoulomb. Millicoulomb. So while voltage across the element is V equals 2 cosine 4 pi t. So find the power delivered to the element at t is equal to 0.3 seconds and calculate the energy delivered to the element between 0 and 0.6 seconds. Okay. So, pag multiple choice, papayagan ko kayong mag-calculator kahit walang solution, okay lang. Pwede nyo gamitin yung integral sign sa calculator nyo. Pero pag problem solving, syempre kailangan ko makita yung solution. Okay? So, dito, we have given charge. We are given charge, but we are not given the current. But we know that I is equal to our dq over dt. Right? Wherein, derivative of charge is equal to, okay, charge muna tayo, is equal to 10 sine 4 pi t. So 10 sine 4 pi t millicoulomb. So therefore, respectively, pag kinuha natin yung derivative ito, we have 10 sine 4 pi t. So with respect to t, of course, I will have a value equal to 10 multiplied by the derivative of my sine 4 pi t with respect to dt. So, we'll have a value equal to the derivative of sine is cosine, ba? So, cosine 4 pi t multiplied by the derivative of u, which is 4 pi t with respect to t. Okay, so huwag niyong kalimutan, no? Alam ko naman gawin niyo yan. So therefore, I will have a value equal to the derivative of 4 pi is 4 pi. So therefore, I will have a value equal to 4 pi multiplied by cosine 4 pi t. So that is our I. Okay, so recheck nyo lang ng mabuti. Baka nagkamali pa tayo. Next. After solving for our I, syempre, ano ba yung requirement ng problem natin? Power. So, diretso na tayo. So, power is equal to my VI. But what is my V? My V is equal to 2 cosine 4 pi t. So, you have to cosine 4 pi t for my power, of course, multiplied by 40 pi cosine 4 pi t for our current. So from this, I will have a value equal to 80 pi cosine squared 4 pi t. This is our well. Okay? So pag kinalculate natin yan, shift mode, mode muna, shift mode 4. So nag-shift mode 4 ako, pag may calculator ka, para change mo yung unit of measurement for degree of your angle from degree to radian. Okay? Shift by cosine 4 pi alpha x. Okay? Squared. Calc at find the power. So P at T equals 0.3 seconds. Okay? So I will have power is equal to 164.5 watts. Okay, but watts hindi. This is my power. So mapapansin mo, makamillicoulomb ka. So yan, millicoulomb. And then naka-volts tayo. Okay? So from here, I will have a value equal to I is equal to naka-milliampere ka. So therefore, milliampere multiplied by voltage. So therefore, naka-milliwatt ka. Okay? Okay? So para sa mga tamad mag-calculate, itong gagawin natin. So we have 80 shift pi. Okay? So cosine 4 shift pi. Next time guys, pag gagawa kayo ng mga magsasubstitute, mag-alpha x na lang kayo or mga alpha a, ganyan, di ba? Alpha a. Basta variable, wag mong gagawin na substitute mo yung value kasi mas matagal. Okay? Squared. So, mapapansin mo mamaya, para hindi ka na mahirapan, magkakalk ka na lang. Tatanungin naman kung anong value ng a mo. So, pag sinabi ko yung value ng a ko is equal to 0.3, di ba? So, 0.3 is equal to 250.24. Tama ba yan? Mali. That is wrong. Bakit? Because of this. Naka-degree. So, dapat i-rad mo. So, therefore, dodoble tayo. Copy. Hindi ba pwedeng copy yan? Sige, hindi na. So, 80 shift pi. So, cosine 4 shift pi shift pi alpha a squared. Okay. Ayan. We have 164.49 milliwatts. Okay. So, itong rod at dig natin, pag nakikita mo yung sinuturo ng pointer ko, it's very crucial. So, yan. Pwede niya kayong ipasa yan, pwede niya kayong ibagsak. So, pag kailangan mong i-perfect sana yung final exam mo, tapos halos lahat pala naka-degree ka, akala mo perfect mo na, tapos hindi ka pala nakarad, so therefore, sayang. Diba? So, very crucial yung rod at dig na yan. So, dapat alam nyo kung kailan kayo magdadeg, alam nyo kung kailan kayo magrarad. Okay? So, yan. So, that is our power. Next is calculate our energy. So, pwede ba natin i-calculate ng ating energy gamit ng ating calculator? So, actually, pwede. Titignan ko pwede sa calculator to. So, cosine 4 shift pi alpha x from 0 to 0.6. Try lang natin, no? Pi cosine 4 pi squared. Okay. So, power, or power, energy, I should say, or W, is equal to the integral of our PDT. So, pag walang sinabi na assumption na may W ka, okay na to. Okay? From TO to TF. Actually, tinry ko kaninang umaga kung pwedeng insert dito sa ating calculator to. Pero ayaw niya. Pero dito sa calculator ko na 991 yes, okay naman, di ba? So, pwede lang sana na i-insert mo na lang yung ating integral sign. Okay? Sana yung ating integral sign dito. Ito. Okay? From 80 shift pi. Okay? 80 shift pi multiply by cosine 4 shift pi alpha x squared. Okay? So, pwede nyo lang gawin to sa 991 nyo pag multiple choice. Ha? So, yan. Okay? But from 0 to 0.6, operation is not supported. Okay? So, operation is not supported. Pero sa, okay, andito, lumabas. We have 78.337. Okay? So, kanina, hindi niya mapalabas sa first class natin. So, W is equal to, insert mo lang to, the integral of 80 pi cosine squared 4 pi t from 0 to 0.6, which will give you 78.337 millijoule. Okay? Pero, pag problem solving, syempre, solve natin to. So, paano ba natin solve to? So, kanina, medyo nakalimutan ko, no? But ay nakuha ko pa rin. So, ang gagawin natin, 80 pi, no? So, integral of our cosine squared 4 pi t. Okay? So, pag mga ganyan, balik-balikan nyo lang yung trigonometric identities. But, eto, makukuha mo sa double angle formula, di ba? So, angle, so huwag natin kalimutan yung ating dt. So, dt. Okay? So, from here, I will have a value equal to 80 pi multiplied by yung integral nito. So, integral of cosine 4 pi squared. So, take note that this cosine squared theta can be rewritten as cosine 2 theta plus 1 all over 2. Okay? So, tama ba? Paki-check na lang kung tama. So, dinerive ko yan kaninang umaga. Okay? So, we have the integral of cosine 2 theta plus 1 all over 2. So, multiplied by our dt. So, yung theta natin dito is equal to 4 pi t, of course, di ba? So, from here, so pwede ko nang ilabas yung 2 dito. So, 40 pi integral of cosine 4 pi t, so 8 pi t plus 1 dt. So, from here, kukunin natin yung integral ng cosine, which is equal to, so 40 pi multiplied by cosine 8 pi t. So, we have sine, di ba? Sine 8 pi t all over yung neutralizing factor natin, which is equal to 8 pi. Okay? So, plus the integral of t is equal to t. The integral of 1 is equal to t. So, hindi ko nilalagay yung ating tas c kasi nga pa naman tayo, definite integral. So, from 0 to 0.6. Okay? So, yan. Ilalagay ko lang muna sa calci ko. So, sine 8 shift sine 8 shift pi 8 sine 8 shift pi alpha x all over h shift pi plus alpha x multiplied by 40 pi. So, calc, pag 0 yung nilagay natin, you'll have a value equal to 0. So, therefore, we have 0 yung lower limit natin. Tapos, pag nag-substitute tayo ng 0.6, so calc 0.6, so you have a value equal to 78.337. Take note that this is at millijoule. So, therefore, the answer will be 78.337 millijoule. Okay, so parehas lang sila. So, paano yung problem solving, yung tinatanong, so, ito yung gagamitin natin ng method. Pero pag multiple choice, okay lang to. Okay? Saan? Actually, parehas lang naman yan. Saan? Problem number 3. Next, we have our problem. Okay, so na-recap ko lang paano ginawa. So first, kinuha muna natin yung I, dq over dt, kasi nga kailangan natin yung current. After nun, kinuha natin yung VI. Okay? So after ng ating VI, ang next na ginawa natin is sinubstitute natin yung value ng t, which is kinuha na yung power. Instantaneous power to, no? So instantaneous power at 0.3 second. Okay? So after natin yon makuha, so wag natin kakalimutan yung ating mga units. So therefore, naka-milliampere to, multiplied by volt. So therefore, we have milliwatt. So after natin makuha, tinatanong ng problem kung ano yung ating energy. Okay? So after natin makuha yung value ng P, so actually, pwede na natin calculator technique agad. So ilalagay natin itong buong to sa ating calculator. And then may makukuha kang value which is equal to 78.37 millijoule. Pero pag minalas-malas ka naman, wala kang makuha ang value. So ang gagawin natin, punta tayo sa mathematical method wherein integrate natin siya, which will arrive to the same answer. Okay? So ganun lang yan. Okay, so problem number 4. In our problem number 4, dito natin makikita yung ating summation of power is equal to 0. Okay? So this is very exciting problem. Kasi nga, dito natin mapapatunayan that power absorbed are power delivered are those power with negative value, and then yung power absorbed that are element that are absorbing power are the elements with positive value. So if we read the problem, we'll see that show circuit with 5 elements if P1 is equal to negative 205 watts, P2 is equal to 60 watts, P4 is equal to 45 watts, and P5 is equal to 30 watts. So calculate the power received or delivered by P3 or the element number 3. So, mapapansin mo that P1 is equal to negative 205 watts. Yung P2 natin is 60 watts. Yung P3 natin is equal to unknown. Nakaparallel man or series yung circuit pag tinatanong yung power summation agad. Okay? Kasi nga conservation of energy tayo. So P4 is 45 watts and then yung P5 natin is 30 watts. Okay? So dito natin i-apply yung summation of power is equal to 0. Right? So from here, you will see that we have negative 205 watts plus our power 2, which is equal to 60 watts. Okay? Plus our 45 watts plus our P3, which is unknown, and plus our 30 watts. Okay. So, lalagay ko na lang sa equation. So, 0 equals P1 plus P2 plus P3 plus P4 plus P5. So, take note that this is equal to 0. Yan. So, pag kinompute natin, we have negative 205 plus 60 plus 45 plus 30. So, yan, makakakuha tayo ng 70. Okay, so para sa mga solve, no? We have negative 205 plus 60 plus 45 plus 30. Right? So, we have negative 70. So, therefore, from this, we have negative 70 plus P3 is equal to 0. Right? So, therefore, P3 is equal to 70. Yan. Tinatanong din niya kung yung P3 daw ay nagre-receive or nagde-deliver. So, based sa sinabi ko kanina, or theorem, or let's say law na lang, is that if you will have a positive value of power, so therefore, this is absorbing or this is receiving. Okay? So recap lang, summation of P is equal to 0. So after that summation of P is equal to 0, nakuha natin yung value which is equal to negative 70 plus P3. Okay? But P3 is equal to positive 70 kasi transpose natin yan. And then, based on our observation, this is positive. So therefore, this is absorbing power. Okay? Seal lang yan. Next, we have our problem number 5. Yan. So, calculate the power absorbed or supplied by each element. Okay. This is the tsura ng isang series circuit. So, take note na pag series circuit yung pinag-uusapan natin, yung pinaka-notified na identity nito is that yung current is always equal. Okay? Equal to all elements. So, passive man or active yung element. So, from here, pinakita yung direction ng ating current. So, take note that 4 ampere, so P1 natin, is entering the positive terminal of our 6 volts. So, 4 multiplied by 6, so this is equal to 24 watts. So, take note, pag resistor yung pinag-uusapan, positive at positive siya because resistor will always absorb power. Okay? So, P2, we have pumasok yung 4 ampere natin sa 3 volts. So, we have 4 ampere multiplied by 3 volts. So, therefore, we have 12 watts. Okay? Kung kahit saan man pumasok yan, pag resistor yung pinag-uusapan, tapos walang sign convention, always assume pa resistor is positive. Okay? So, yan. And then, take note, itong 4 ampere natin pumasok sa positive 3 ampere, and then, pumasok ito sa ating negative 9 volts. Okay? So, therefore, P9 volts is equal to 4 ampere multiplied by negative 9, so you'll have equal to negative 36 watts. So, from this problem, you may say that P1 is absorbing power, P2 is absorbing power, and P3 is supplying power. Okay? So, para mapakita natin yung formula, yung theorem natin that summation of P is equal to 0, siyad natin silang lahat. We have P1 plus P2 plus P9 volts. So we have 24 plus 12 less 36, which will affirm our theory. Okay? So, ayan. So, problem number 6. Hindi gumalaw. Okay. Okay, so hindi ko rin solve to, no? Actually, titigan nyo lang yan. Pero may nasolve po to sa code 471 na pan namin to. So, pag gusto nyo mag-extend ng kahit 3 minutes lang, so isolve natin. But, fortunately, baka ayaw nyo na. No? So, 6, parehas lang naman yan, no? Ang gagawin mo lang dito, ang gagawin mo lang dito is kunin mo lahat ng time ng burner. I-add mo lahat yan, tapos i-multiply mo siya sa rating nito, which is equal to 1.2 kilowatt. And then after nun, kunin mo yung oven, i-multiply mo sa rating nito, And then pag adin mo yung dalawang yon, after nun, makukuha mo yung total energy, and then imumultiply mo yung ating 12 cents per kilowatt hour. Okay? So yan, baka tignan nyo yan, baka lumabas sa exam yan, no? Okay? But, wala tayong exam ngayon. Okay? Wala tayong exam ngayon kasi kawawa yung code 474 at 475, which is hindi pa sila katatapos lang ng kanila, ng conceptual problem nila. Tapos, laging walang kuryente pag Sabado. At pag Friday naman, laging may seminar. Okay? So, for your attendance, screenshot nyo lang lahat ng ating first at second, no? So, i-keep nyo na lang muna yan kasi nga bawal magbigay ng assessment kayon. Okay? Kasi pag binigay kong attendance lang to, kawawa naman kayo sa ating learning task, di ba? Kalahati to, di ba? So, katulad pa rin ng dati, open cam para mas mataas yung puntos. Okay guys, pag nakapag-attendance na kayo, salamat sa pag-attend and you may now leave our meeting. So, good night guys.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.